In this screencast, we're going to kind of build on the idea behind significant figures and how we interpret them, and then now we're going to do calculations with them. So this is again something that has to be honest and authentic to the precision and to the numbers that you've collected using the devices you've used. So to kind of start this off, let's talk about something as simple as rounding. Rounding is pretty straightforward. You have a bunch of numbers, you got to cut it off at some point though, and then round appropriately. So we're going to look to the right of whatever digit you need to round, and then basically round up or round down accordingly. Round down if that digit to the right is from 0 to 4, or if the digit to the right is from 5 to 9, you're going to round up. So that's something, again, just keep in mind. This is hopefully not too new to you either. All right, so for each of these, I'm going to ask you to round to 3 significant figures based on the numbers given to you. So let's say I have a calculator number as 0.3932. Now I have to round to 3 significant figures. So at this point, you still have to apply all those rules that we saw earlier about how many significant figures are there and how many I'm supposed to use. So let's kind of break this one down. First of all, which one of these do I need to keep? Well, if I notice the 0 in front, right, the 0 point some, that corresponds to a leading 0. Leading zeros are never significant, so I really shouldn't start there. I really should be starting here where my first non-zero number is, and then count from there. So 393, right? So all 3 of these here, let me underline that better, all 3 of these here are the ones I want to keep because I want to keep 3 significant figures. So then I look to the right of that. So if I look from 3 to 2, that ends up making the 2 round my 3 down to just 3. So the correct answer for this one just ends up being 0.393. Number 2, 0.08 and a bunch of zeros and 2. So let's kind of take a look. Zeros, again, are typically the ones that are most confusing, so let's go ahead and deal with those. At the beginning, I have 2 leading zeros. We just remind ourselves that any leading zeros are always insignificant, so those do not count. So we're going to start with the 8 as our first non-zero number, and then 1, 2, 3. So I want those 3 numbers to be the ones that I keep. If I look to the right, I notice that this next one is 0, so I'm going to round my other 0, the one just to the left of it, the one I want to keep. I want to round that down to 0, so this one would be correctly written as 0.0800. And yeah, of course, you can always do it as 0.0800 if you desire. All right, the next one you have 3, 6.2915. Okay, so 6, the first number, yeah, we're going to keep that. And then we go ahead and count 3 after that. We're going to count to 2 more after that. So get a total of 3 significant figures surrounding that would be 6.29. Right. I'll let you go ahead and try the other 3. As you can see, number 6 is a little bit tricky. So go ahead and have a crack at that one, and we can discuss that later. When it comes to calculations, right, we're going to do a lot of calculations with the measurements, right, the values that we actually had to measure. So the general rule is that we always go with the least precise, or the one with the least significance. Now, what that means, it depends on the type of operation, which we'll talk about in a minute. Let's be very clear. Right now, you should go ahead and set it up in your mind. Anything with addition and subtraction, those are going to have its own rules. And then completely different rules. We're going to have multiplication and division, right? So those are 2 separate sets of rules. Addition and subtraction are basically opposites of each other. And in kind of the same way, multiplication, division, those are kind of within the same family of each other, like the kind of opposites. So we're going to treat those as separate rules within themselves, as comparing to the other type. So addition and subtraction, its own rules, and then completely different rules, multiplication and division. Finally, you will always do order of operations. Nothing's changed there. I've used this PEMDAS. Please excuse my dear Aunt Sally. Some of you use different things. But of course, we always do it in that order to make sure we are following the order of operations as is appropriate. Okay, let's talk about this one. Addition, subtraction. Now, this is again the first type of calculation, addition, subtraction. The language says, when adding or subtracting the calculated value, so the answer that you get out in the end, that you should report, will have the same precision, right, and this is where it's underlined, as the original values with the least precision. All right, so kind of calling back to what we just saw a minute ago in the previous slide, we're always going to use the least something as our guide here. In this case, it's precision. If you remember, precision, another fancy, this is just a fancy word anyway, of saying which one has the least number of decimal places, right? Least number of decimal places, or fewest, I guess is probably the most appropriate word. Number of decimal places. So what I'm going to do is go ahead and take a series of numbers that I'm going to add and subtract, like 1.03, 9, 4, whatever, all this is right here. And again, you can go ahead and do that math. No problem. Just stick them all in. Right? Don't worry about rounding. Don't do any of that stuff yet. Always do that at the end. The result of this is going to be 95.13318. Right? So again, you can stick this in your calculator. I'm not questioning your ability to plug some numbers in and get an answer out. I am questioning your ability to interpret these according to the rules of significant figures. This is an example of an addition/subtraction problem. So I'm going to base my answer off of my original values and the least amount of precision. This one is precise down to the hundredths place. This second value is precise down to the tenths place. And this last one is precise down to the something thousandths place. Okay, all right, whatever it is. When I look at these three, the one I'm going to base my final answer off of is this one right here because it has the least precision. This one only goes down to the tenths place. It's only point something. So my final answer must also be down to the point something. So my final answer for this one ends up being 95.1, right? My 3 rounds this down to a 1. That's my correct value that I would report. The reason is I don't have precision with this second number right here like I do for this one and this one, right? This, like I said, this one goes all the way down to 5 decimal places. That's a very, very precise instrument, very precise thing that you use to measure something. But this one doesn't have that precision, so I can't carry super precise with this sort of more rougher and more sort of blunt object to be able to measure with. Performing an old school method can maybe helpful too. Can be helpful to you too, where you write it out like 1.03 and then the 94.1 and then 0.00318. Sort of line it up, and you can see here, right? Based on that alone, I know that this is where I'm going to round my final answer. So again, I rewrite this, I rewrite the calculator answer if you need to, but 95.1 and then 3318 again, right? I know that's where I'm going to round, so I make the 95.1 and then round it. Anytime you do addition subtraction, you use this process. All right. So back to this one again, thinking about this with the apples. We have these same apples. I have one scale that reads to the thousandths place. I measured it to be 6.293 pounds. My friend in the second scale, which is again only reads to the tenths place, reads it as 4.5. So how much should I be able to report as the total mass of all of my apples? Again, I can stick this in my calculator and get a number out, but I can't just use 10.793 pounds as my final answer, right? I can't do that because, once again, this doesn't have the precision that the first scale does. Right? I can't carry that out. So my final answer, again, I round it. Since this one only is precise down to the tenths place, I round this value down to the tenths place. So 10.8 pounds is the best I can report for the total weight of my apples. Give me some practice here. All right, so giving you an idea of how this lays out. Once again, use those same rules of addition, subtraction. In the bottom, you have some answers that you can check against. All right. Now, let's flip over to the other side, multiplication, division. Multiplication and division, like we said, is its own family of rules. It's very similar in terms of language, but there's a very important distinction. Let's read it out. When multiplying or dividing, the calculated value will have the same number of significant figures as the original values, with the fewest. All right. So as a reminder, right, I'm not going to go back, but if you look at the addition subtraction rules, it actually says, instead of significant figures, it says versus precision. Okay, one more time. Precision refers to how many decimal places it has. Significant figures is just how many significant values there are. Right? It doesn't matter where they are, what decimal place they might end in. But in this case, right, that's what we use to determine our multiplication division rules. All right, let's put this into practice. So this one right here, 1.03 times 94.1 times 0.00381. Right? Again, previously it was plus. Now it's times. What do you get out? Your calculator will spit out 0.308211514. Right? Well, again, that is not something we can really carry because we don't really have that much precision. So what I'm going to do here is take a look. I know I have 3 significant figures here, right? So significant 1, significant 3, and that 0 between it is also significant. So that's a total of 3. This one has a total of 3. This one has a total of 3 significant figures as well. So 3 versus 3 versus 3, I'm going to choose the one that has the fewest number of significant figures. Well, as it turns out, they all have the same number of significant figures. So my final answer will be rounded to where it has 3 sig figs. Again, not 3 decimal places, but 3 significant figures, which coincidentally ends up being 3 decimal places, 0.308. Right? Make sure that you don't look at this later and think, oh, I rounded 3 decimal places versus 3 sig figs. Right? I have 3 values here. All right, so putting this into practice here, you have a bunch of them. I'll do the first one with you just to make sure that that point wasn't clear enough. So this first one, I'm going to go ahead and do some numbers. My calculator gives me 39.31865738. All right, that's lots of numbers. And as you can imagine, you don't really want to write them out. So what you're going to do is you're going to look at your significant figures, and I'm going to jot down how many they have right above it just to remind myself. That's 4. This one has 3. This one has 5. So 4 versus 3 versus 5. The one with the fewest sig figs is that 204 in the middle. That's 3 sig figs. So I'm going to round my answer also to 3 significant figures. So I'm going to write 39.3 as the final answer. You're welcome to write out whatever you need to in the process of getting there, but your final answer has to be 39.3. All right, go and try the other ones out as well. Now, mixing types of calculations. So this is important because you need to be able to know when to apply certain rules and how. So first of all, order of operations is always important. That never changes, right? So please excuse my dear Aunt Sally, which is parentheses, exponent, multiplication, division, and then addition, subtraction, right? These are kind of its own little order. Right? Do those first in those orders. But then again, anytime you change the type of calculation, right? Anytime you change from addition, subtraction, multiplication, division, you need to change the type of work, right? Change the type of roundings. So be careful here. Let's take a look at this bit right here. Right? 44.03 plus 103 times 0.39. All right. First of all, remember you have to multiply these two first, right? Order of operations. And that ends up being 40.17. Right? So some of you might find this easier, or at least a little more clear to write it out as 44.03 plus 40.17. Okay. Now, I haven't actually quite finished yet because this first calculation, right, that's multiplication division. I have to round now because I'm looking ahead and knowing that my next calculation is going to be a addition subtraction. So that's going to be a separate kind of rule, a different kind of rule. So anytime I change the type of rules, I have to first do my rounding and then do the next operation. So I'm not even going to worry about this just yet. I'm going to go ahead and round the 40.17 appropriately. So I'm going to cross this out because that's not what I need right there. I'm going to go ahead and round the 40.17 appropriately, looking at my original values. That's 2 sig figs. That's 3 sig figs. So my next, or my rounding here should really just be 40 point. Right? Now, once I have that rounding done, right, because I'm going to change the type of calculation, 44.03 plus 40, that's going to equal now, going back to blue, 84.03. All right. Now I can round it again based on the significant figures rules of addition and subtraction. Addition and subtraction is based on the fewest precision or least precision or the least number of decimal places. So in that case, it's going to be the ones place. So I'm going to round here, and my final answer therefore has to just be 84. Now, you can, again, technically plug in all these numbers at once and then round it all at the end. For example, I can just take 44.03 plus 103 times 0.39, all my calculators, so that it does all the order of operations for me. However, that does actually end up changing the value a little bit to where you might actually end up getting a totally different number that's wrong. So be careful. Right? This is not something you just want to casually throw in all at once. You do have to separate each step to get this correct value every time. You have 2 more practice problems. Go and give those a shot. Those are ready for you. All right. Finally, this is one that is a little bit one you have to kind of keep in mind. Calculations with constants or exact values. Constants, remember, these have infinite significant figures, or exact values have infinite, right? These are the ones where you count, or, you know, it's very specifically defined a certain way. So in this one right here, right, how many feet are in 33.24 inches? Well, if you do the work, again, not really going to have to do it for you necessarily, right? You're going to do 33.24 inches, changing it to feet. You end up dividing it, right? So divide by 12, right? So this is, again, not really going to help you out some, because your answer of 2.77, you just write it out because that's what your calculator says, right? Your calculator says 2.77, so that's all you're going to write. But remember, since this has 4 significant figures, let me change the colors. There's 4 sig figs here, dividing it by basically infinite. 4 has fewer sig figs than infinite, so you're going to round your final answer to 4. So you have to make it 2.77, and then that's 0 at the end there. Second one's very similar, right? Determine the average of 10.03, 10.12, so on and so forth, right? Stick those numbers in your calculator, and your answer will just be 10. Why is that? Well, if you think about it, right, 10.03 plus 10.12 plus 11.92, right? You end up ultimately dividing all of that by 3. Some of you are thinking, okay, well, that 3, that's only one significant figure, so if I divide by one number, right, a significant figure of 1, my final answer will also have just one significant figure. And again, we have to be careful here because ultimately this has infinite significant figures. So that really should have 0 effect because infinite will always be more than whatever you're doing the calculations with, right? Your measured values. And your measured value is the one that's least is always the winner, not the biggest one. All right. Here's a bunch of mixed practice, kind of giving you a chance to apply them. Some of these are going to be all within the same family of significant figures. Some of these won't be, or types of calculations. Go and give these a shot, and again, you have the answers to compare against there. All right, that'll do it.